falling into ruin, is the best way to put it. And so the Israelis, Jewish tribes, weren't doing so well. They got conquered. Okay, they got conquered by a group. And so this cat, Hezekiah, goes to the king of Assyria and says, look, I want to rebuild the wall around Jerusalem so that my people will have a place to go do religious activities. Okay? So the king says, great, we got a lot of money. We're going to do a public works job. I want to pay for you to do this. Go do it. So he gets back into Jerusalem, and the folks there say, I don't think it's such a good idea. Okay? He says, look, I got a letter from the king. We're going to rebuild this deal. Okay? So he begins, at that point in time, to take the remnant of the Jewish people that were in Assyria, which is now Iraq and so forth, and Iran and so forth, and he brings them back and he organizes them. Okay? And he organizes them into teams. Okay? So what I'd like you folks to do, somebody be a scribe, somebody be a writer, and somebody, let's go through activity. Okay? So on the left-hand side, put down team, and then here activity. Okay? Okay. So the first group, you had these high priests, okay, and his fellow priests, which is amazing they get any work out of a priest, right? They dedicated it, okay, and what did they do? What did they build? Sheep's cave. Okay? We're going to call those P and P's, okay? Now,
You said a sheep's gate?
sheep. See up here? Sheep gate.
Oh,
Okay.
sheep gate.
Sheep gate was the activity. They dedicated the sheep gate, okay, they got through with that, set doors in place, and they built as far as the Tower of the 100, okay? And so they not only did the sheep's gate, they came over here to, let's call it the two towers, okay? So they had on that wall, if you think about a wall going around a city, they went from the sheep's gate to the Tower of Hanel, okay? You may see that on that picture. I don't know. It may be there, it may not be there, but they named all these things and you can kind of see them just to give a visual reference. That would be like, hey, I want you to go from column line C1, okay, to C5. All right? John, that's your crew, okay? You're going to do that with all the Baptist ministers, okay? Yeah. See you in a couple of years. All right. All right, so next group was what? What was the activity? Fish gate. Okay, now, here's the thing you have to remember, okay, let's think again about what was the purpose of the temple, okay? They did what at the temple? They did sacrifices, okay? The Jewish religion, they had to atone for their bad deeds, and they did that by sacrificing. And so they sacrificed all kinds of stuff, okay? Oil, wheat, sheep, goats, birds, you name it, okay? But because they did not have modern refrigeration, what did they do? They segregated the types of animals into different areas. So the sheep that were being sacrificed were brought in through the sheep's gate, okay? Fish gate, what came in through the fish gate? Fish. There you go. So I've taken some liberty here because a lot of times these names from antiquity look pretty, we just modernized some of them. So we had Harry over here, Harry and his team. Okay? They did the fish gate, okay, and the section. Zach did this, okay, which I think is great. You know, people have always been complaining about managers. I highlighted this, okay? I think it's great. The next section was prepared by the men of Tulsa, but their managers would not put their shoulders to work under their supervisors. I thought that was great, okay? Even back in antiquity, people are bitching about the boss, okay? So, they went over and they did the next section, okay? Then this Jeshana gate was repaired by Jody, okay? And then some repairs by McDonough, okay? Then they had goldsmiths. And so they took the walls around Jerusalem, and each group of people was assigned to a task, okay? The Alma Gate was repaired by Dennis and so forth. The residents of Marietta, did you like that? Yeah, okay, fine. All right, so what's the point? What did they do to repair the walls? First thing they did is that they had a task that they were trying to do. And what was that task? Build a wall. Right? They were building a wall. They then took a look at their available resources of people and product, and they broke it down into specific sections of work. Okay? And then what did they do? They went to work. They went to work. What they did in antiquity, we do every day. Okay? The reason I bring this up is simply to say, anytime you go back through history, with any ancient structure, you will find that the procedures and techniques that they use to plan are exactly the same thing we do today. Okay? So, when we begin a task, we take any task, we say we got to start it, we have a finish. But what comes before the start? Talking about this, planning comes, what comes before that? An idea. An idea. The owner has an idea of what he wants in a building. He has the architect put that into plans and specifications. And from those plans and specifications, we turn that into reality. Okay? So where are we in this line with our scheduling and planning? We are in between the concept, the idea, the concept, the preparation of working drawings, okay? And now we're in between the working drawings and the actual physical commencement of work. That's where schedule occurs, okay? Does that make sense? Okay, all right. All right. Everybody here has got a book on CPM scheduling, okay? And in this particular book is broken down into sections. Section 1 is the pre-project planning phase. Pre-project planning phase. Now on the back table back there are plans on Live Oak. If everybody will, one person with the table, go get a roll of plans on the building and get them up on the table. Get that off the screen.
You got props.
Okay, we're going to start on sheet,
Did you find it? You did. Okay.
2S 2.1. 2S 2.1. Look at the bottom right-hand corner. 2S 2.1.
Here, I've got this. This stuff works better.
Great.
And I can help you with the computer along.
All right. Okay. Everybody got the blocks? Okay, open up your blocks. Yeah. They just throw them all out. All good, nothing special. Do not throw them at each other. Okay, find your A, B, C, D, E, F, G. Put them in alphabetical order.
I don't have a certain block.
Here, right here. We got it. There's the name, there's the fee.
Okay. Tell me when you got them in alphabetical order. I don't care if they're in a line, I don't care if they're up and down, however y'all do it. A, B, C, D, E, F, G.
Brian, you want to hop up with those two so you can work in a team?
How you want to do it, Brian? It's all good.
Yeah, if you want to run solo. All right.
No, they're all in there.
Okay? You got it?
Side.
You have 2 rows of MNOP or MNO on both sides.
Okay. They're trick blocks.
Okay, so what do we figure, what you figured out is that we just did some pre-project planning, right? What the heck am I doing here? Okay, so when we think about what the activity, okay, what we're gonna run a quick schedule on right now is the footing pour for the shops. So if you could go down, Darcy, to where we just see the floor plan, so come down.
Yeah, this is down.
Yeah, come down further. We can see the whole thing.
And, Newport.
Okay. So on our pre-planning size, this is the goal. The goal is to pour the footings for the shop. Okay, so we have a series of shops, we got a set of shops, we've got footings, continuous footings down the back of the shops, the right side of the shops. We've got a turn down and footings on the front and some isolated footings, and then a footing running along column line 8 and 2.05. Okay, everybody clear on that? Okay, what are footings? Footings are the supports for the building. Okay, these are typical spread footings. They're not specially finished, they're not grade beams. So we're going to be bearing them on dirt, right? Going to be bearing them on dirt. And so from a pre-project planning phase, what do we need to know about those footings?
Elevator.
All right, first things, start here and we'll go around. Go. Okay, you need to know dimensions. Okay?
Soil?
Okay, soil barrier, that's good. Rebar size? That's good, okay. Let's just say concrete rebar.
Concrete strength?
Okay, so we got that. How about elevation? Okay, you need to know the elevation. Lisa? Lisa, you got anything?
Hey, no, I don't.
Okay, that's all right. Jonathan?
We're gonna lay them out.
Okay, you need, well, we said dimension, that's up top, okay? David, any ideas? It's okay, look, this is not, we're not trying to put anybody on the spot, just trying to get some idea. Okay, okay, we need to, let's call that material handling.
The amount of concrete.
Yeah, okay, so we need quantity. Okay, we need material handling. Okay? How about location? We got dimension, but you need to know labor. Okay, labor, equipment, quality control, right?
Whether it's being poured or pumped.
Yep, that's under equipment,
Okay.
right? Okay, how about material procurement? You know what I mean by that?
No.
Where you get your concrete from?
If you don't have the rebar, you don't know where the concrete's coming from, you don't have your rebar, you don't have your anchor bolts, how can you pour footing? Right? What else are you gonna procure besides the things going in the ground? Might you need formwork? Okay, Live Oak, Florida, sandy soils, right? Probably not gonna be able to use the side of the dirt down there for a footing, maybe, maybe not, okay? Might need forms, okay? On the equipment side, okay? Do you have a benchmark? Okay, do you know what you're laying out from? Are batter boards up? Okay, have they been checked? Okay, so when we go through our activities, the first activity, which we will call A, take your A block and put it first. Okay, just move it up on top, there you go, there you go, now. So we gotta get material on the job, material procurement, right? We know we gotta have material on the job, okay? Second thing you need to do is that you gotta have dimensions, which we'll call batter boards, BB, and layout. Okay? I know I got material coming, and then I gotta lay out the work, right? And our batter boards are our building until the building is built, right? Put up your batter boards, they're set at a certain elevation to measure from, okay? You pull string lines, right? Or that string line can be optical, it can be an actual piece of string. You check the square and dimension of the building, you check your layout, and before you commence physical activity, you do quality and assurance. So that's block C. First, quality check. Oops, that's B. And quantity, where's quality?
Nine.
Here's C. There, okay? What's next?
Equipment.
Quality control, we said procurement, here's A again. Okay, now, once we know where the building's going, we have a general idea about what the activity is going to be, right? So we've got to get equipment, A, B, C, D, and labor on the job, right? Okay, and what have we done so far that has actually constructed that building up to this point? No physical work has been done, except batter boards and layout, okay? It's okay, you had to do all of that because if you do all of that correctly, it allows you, when the expensive stuff gets on the job, to go from 43% to 82%. Okay? Quick example. You get a backhoe on the job. Backhoes rent for how much a month now? $2,000, $2,500 a month. Okay? If I dig 100 yards of footings, 100 cubic yards of footing dirt, okay, and I have a backhoe that's there for a week that cost me $500, how much per cubic yard did the excavation cost? 500 divided by 100, $5 a yard. If I leave that backhoe out there doing nothing all month, that 100 yards of concrete or that 100 yards of footing excavation cost me $2,000, so it would cost $20 a yard. Okay, so if you think about it like this, anybody ever bought an engagement ring here? I know you haven't, but anybody ever gotten an engagement ring here? Okay, how do they sell diamonds? By the carat, right? Very, very small unit of measure. Are diamonds cheap? No. No. Okay. How do they sell stone? By the ton. 2,000 pounds versus a fleck. Okay. General rule of thumb is the more expensive something is, the more you need to pay attention to how much it costs. Okay. Now, you got to have quality control, be sure your footings are dug the right size, correct? Okay, so you then begin the physical activity. Now, under the equipment side, okay, you also have to have ways to have your elevation right, correct? So you got to have a laser on the job or an optical level, whatever you happen to be using. At that point, you're gonna do what? You get the footing excavated, what happens? Rebar, right? Okay, then what has to happen? Inspection, and then what?
Concrete.
Pour that damn thing before it rains, okay? Pour it before it rains. All right, so what I want you to do, okay, is to take your blocks, okay, and on a piece of paper, I want you to arrange your blocks like this. You have activities that can all start at the same time. Right? What we just went over, correct? And what would those be? You could start material procurement, right? And you could start battlebords and layout at exactly the same time. So put your A block above your B block. There you go. Like this. Let me show you. That's good. Oh, boop, boop. We're going to go from left to right. Okay? AB. That's good. AB. Yeah, it's okay. You got AB. Everybody got AB?
You're feeding us.
Where's AB? Come on, man. AB. You got AB? All right, you got AB? All right, let's put them, really, let's put them like this. AB in a line. Okay? Put them up and down. There you go. Now, what we're doing is we're doing what's called a quote block diagram. See, wood blocks. I used to be called a blockhead when I was a kid. Okay, so we got our A block and our B block. And as we go from left to right, this is going to be time. Okay? Those two activities start first. Okay? Now, once we finish our battlebords and layout, okay, what's the next thing we're going to do? We're going to come over here to equipment, okay, and labor. Okay, and what did we say we were going to call those?
They were D, what happened to quality control?
Quality control is here too. Put C down here too. Okay. And equipment and labor we call D. So put D. There you go. You got 3 in a row and a D. That's perfect. 3 in a row, perfect. 3 in a row, perfect. 3 in a row, perfect. 3 in a row. There you go. Perfect. 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 Great. Hopefully this isn't too simple, guys. Okay, just trying to get some concepts here. Okay, you got your equipment and labor. Then what are you going to do now? You're going to dig footings, right? Equipment and labor. Actually, we had battlebords and layout, which we had in here in D, which we'd already tried. We're going to dig the footings, and we're going to call that E, right? So put your E. Okay. Then we're going to rebar, which we're going to make F. Okay, G is going to be inspection. Put a G. Is inspection. And then if you see the E, F, G, H is going to be what? Or. Okay? Now, if you notice, what I want you to see visually here is that there are certain activities that can parallel other activities. In other words, they can run at the same time, but there are other activities which are nose to tail. Okay? In old CPM language, I used to call that the IJ precedent. Okay? We tried to find a book from the 60s that I learned from, Darcy couldn't find them, but it was a good book. It was short, easy. Now they got these things this thick. Now, there are activities that each person in the team is required to do under each of these things. Okay? Now, who's going to do material procurement? What's a role, what person on the job has a role of material procurement?
Daytime super, right?
Yeah, daytime super, could be project manager, helps to do the front end work. Okay, we go back a little further. Project manager's got to have an approved mix design, right? He's got to have approved rebar drawings, he's got to have approved anchor bolt drawings. Okay, so before you can, you've got to have some things feed into here from the PM side. But since we're dealing only with the field, we're assuming all that is done, and so we're gonna have a supervisor here, okay? The B, which is your dimension and so forth, is gonna be the supervisor plus concrete foreman. Right? Maybe a laborer will be involved, right? C, quality control, that's supervisor. So as you look at each of these activities, we then come over to equipment labor. Who's getting the equipment labor? That's gonna be over here under your concrete foreman. Okay, assuming we're using a concrete sub, okay? Digging the footings, gonna be the concrete foreman plus labor. Same thing on rebar. Inspection is gonna be independent. Okay, another thing we add here, oops, quality control. Who's doing testing? Have they been lined up? Okay, and then we have the actual physical pour. So let's put some time on this. Let's put some time on this. And let's walk down the critical path. Okay, everybody know what a critical path is? Yep, no? Yes? Okay, all right. Quick definition.
I don't know it, I'm just.
Okay. Quick definition on critical path. The critical path through a job is the longest path from start to finish. When I sum up my activities, the critical path is the longest line, okay, of time, once I add durations, okay? Now, any activity delayed long enough will become the critical path, okay? Will become the critical path.
Why is it called a critical path?
That's just what they
Okay, it
decided
just
to
is,
do.
okay.
That's, blame the Navy,
Okay.
blame the Navy. The Navy started CPM scheduling, and so, here we go. All right, so, how long is it gonna take to procure the material, meat, and so forth? You're down at Live Oak. You just arrived at Live Oak, you got your hotel room, you contacted folks, and you're expecting them to be on the job site, and they call you in the morning, and they say, oh, I have a car broke down on I-75, you know, dog died, you know, et cetera, et cetera. So they show up hopefully the next day, okay? So, let's put on a piece of paper, put 2 days here. Okay? So your activities A, B, and C have 2 days. Getting equipment on the job, being sure it works. How much time? Just say a day for this exam. Okay? For this exam. Okay? So how much time are we're walking down the critical path? What are we up to?
3 days.
3 days. Okay. All right, battle boards are up. Okay? You know, we had this back under quality assurance. Think we can do the battle boards in the first 3 days? Probably. Okay, let's just for our simple thing say that. Let's not necessarily judge the accuracy of the schedule, but to do the schedule. Okay, we're then going to dig the footage. So how long is it going to take to dig all these footage? Yeah, let's put 2 days down, okay? So you got 2 days to dig. Okay, you got rebar, anchor bolts and rebar, and you got to check those, and let's just say that takes 2 days. Okay? And you've already made friends with the inspector, and he'll not delay you at all, he won't stonewall you, and you call him and he comes out in the next 15 minutes because he just likes you so much. Okay? And so in 1 day, you get your inspection, and the next day, you hear, you pour, and then you strip and clean up. It's a day. So let's count that up. We had 2 days that went to 3, which went to 5, which went to 7, which went to 8, 9, went to 10. Does that make sense to everybody? So if you look at your blocks across your paper, that's a 10-day duration. Now, I'm not trying to give you guys productivity models here, but I'm trying to get you to think about how one activity affects the other. Okay, how does one activity affect the other? So, anchor bolts don't show up. Okay? So what can you not pour if you don't have anchor bolts? Can't pour that, 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 can't pour this. Okay? Now, if I've got 20 days worth of footing work to do, I may be able to stagger the anchor bolts. You know, I may be able to do just continuous footings without the anchor bolts here. But for this simple example, we're assuming everything is there. But what I'm trying to get you to think of, if you don't have everything here, you can't do all the work. Okay? So, you have to be thinking ahead to the 6 Ps on everything that you do. Okay, so, we kind of put some days down, but then let's have a little bit more fun with this. So, Darcy, if you would, let me see if I can see this. Go to 4.2S2. 4.2S2. Sheet 4.2S2. You can move blocks. Darcy, come back. Four.
Sorry.
Only two.
Two, whoa, stop. One more.
2.2.
One more down. One more sheet down. I'm sorry.
2.1.
Yeah, 2.2.
Okay.
That's on the sheet. Did I say 4.1? I'm sorry. Did I say 4.1? Go to 4.1. Yeah, you're on the right page. Good. Okay, let's look, just for the sake of conversation, let's look at detail 2. Excuse me, detail 6. Detail 6. Yeah. Yeah, good, thank you. Okay, now we know from looking at at our foundation plan that we have a length and dimension on our footings, right? Okay, so we know if we go back to sheet we were just looking at, we know this building is 100 feet wide by 70 foot deep, right? Everybody good on that? Okay. So using our lessons in geometry, if we got 2 footings 100 foot long and 2 footings 70 feet long, that's how many feet of footings?
340.
340, rough numbers, okay? Now, we would do an accurate takeoff on that. We know that footing by dimension is 2 by 1, okay? So that's 2 cubic feet per running foot, right? So if we're 340 feet long and we're using 2 cubic feet per foot, okay, how many cubic feet of concrete do we need? 2 times 340? 680, right? Somebody divide 680 by 27. How many cubic feet are in a yard? 27. 3 foot by 3 foot by 3 foot. A yard is 3 foot long. Yeah. There you go. You've been practicing. Yeah. What is it? Someone got a calculator here. 25 what?
0.18.
25.18. I don't think they'll let us order a .18 yard. But. So we're probably looking at 26 to 30 yards of concrete, somewhere in that neighborhood. We're slinging numbers right now, guys. Please don't sling them like that when you're buying the stuff. Okay, don't do that. Don't let me make a $120 mistake by going too fast. Okay. So you got 25 yards of concrete. Now, the old rule of thumb is that you ought to be able to place 9 yards of footing concrete an hour. That's an old standard productivity rate, right? So if I've got 25 yards and I'm getting 9 yards an hour, okay, May go faster, may go slower, we'll just use it to do productivity rates. How many hours is it gonna take me to pour those footings?
3.
Three. Yeah, three. So you can then break each one of these items down into individual productivity rates. Okay? Tie and rebar. You get an idea. How much rebar can you tie in an hour? Now, as supervisors and as people watching others work, your job is to start watching and equating what you're actually seeing done, okay, to the person. Okay? Grandfather told me when I started digging footings by hand, and I did dig footings by hand for those of you that may not believe it, it's true. Okay? He expected 1 cubic yard of footing excavation in Georgia red clay per hour. Okay? Pick and shovel, you should be able to dig a yard per hour. Okay? I knew as a worker what the expectation was. So that as a worker, I did not let the available work expand to the available time. Your schedule will help you with that. Does that make sense? Okay. So when you understand how long something should take, given a certain crew size, okay, you find out whether people are working efficiently or not. Now, are you responsible for the efficiency of your subcontractors?
Yeah.
Yeah. Okay. Are we financially responsible for that?
No.
No. Okay. But it's our job to be sure that our subcontractors are working as efficiently as possible. So if they're taking 5 hours a day in breaks smoking cigarettes, as opposed to being out there working, okay, we have a responsibility as a superintendent to call their boss and say, hey, Joe Bob is screwing off. We're not getting any productivity out here. Is this the way you want to do it? Okay? Sidebarring it, but your schedule helps you with that. You see? Your schedule helps you with that. How many pieces of sheetrock should 2 hangers hang in a day? There are productivity rates on that. Work up high, takes longer to work right off the ground. Okay. All of that goes back to productivity rates, and your schedules are going to help you do that. Now, using your blocks, okay, what other activities could be going on this job while we're doing footing excavation? Be doing site work, right? We could be putting in storm drainage, running sanitary lines, running water lines, curb and gutter, depending on where we are. So the goal with a schedule is to run as many activities on a job as you can at its earliest start. Okay? Now, let's do a little quick example. Darcy, I'm gonna race. Everybody need a break, or are we good?
I can erase it while you talk.
Yeah, we're on a roll.
I
Okay.
gotcha.
So what we're going to talk about now is some parallel activities, okay? Now I'm going to do some very, very basic stick diagrams to show you how those things work and how they can help you with what you're going to do. Okay, so what did we just do? We did a very, very simple schedule on putting footings in the ground. Okay, now we're got our footings poured. Okay, and what's the next thing we want to do on the job? Steel. What holds up the steel? You got to have your masonry walls up on this particular building, right? Right? We do want to get the steel quick as we can.
Block up.
Got to get the block up. Okay? So let's go back. We're getting ready to start laying masonry walls. Yes, sir.
Can you run it simultaneously?
Say again.
Can you not run block masons and steel erectors simultaneously?
It depends on the design of the building. Okay, if you have a roof structure that is self-supporting and you have block infill,
Right.
okay, your 4810 Publix and some of the others are freestanding steel structures with some, yeah, you can do that. Okay, but for this example, this particular building, and if we go to sheet, let's go to sheet 2. Here we go. 2S3.1. 2S3.1. There you go. Marcy, right on. Yep. What do we see? Yep, roof framing plan. Now, let's start with our roof framing plan, because what we're trying to do is support the roof, try to get a roof on the building, take weather out of the equation, right? Once you get a roof on the building, you work inside when it's raining. It's kind of a typical goal. Okay, when we take a look at column line 8, 2.05, look at section 10, 2S 4.4. Let's go to sheet S 2.4. Okay, section 10. Yep, 10, got 10, good. You got section, yeah, 4.4. 10. Okay. You got 10. Yep, good for you. 10 over here. Okay, we got 10, great, good job. So, what is supporting that column line? Just stay on that. That framing line.
All right,
We'll
we
walk
got
over
it.
the other. Okay, do we need that block wall up to put up the steel? No. Why? Because you got a row of columns along that line, and then you have a steel angle. Okay, that concrete block wall you see there is actually on this job the wall of the Publix. Okay, so we do not need a block wall there. Okay, let's flip back to our roof framing plan again. And let's look at section 8, 4.4, 2S 4.4, and 1. Go to those two and see what they look like. Okay? So we need to have that block wall up to, excuse me, Jason, to support that deck, don't we?
Yeah, you need that for section 8.
To 4.3, 1 4.3. Once again, it's showing how to put the truss girder in. And that's a truss girder, it's on Joyce Pocket's truss girder. Let's go. See that truss girder? That 28G, there's a truss girder here, a truss girder here, so they're showing a different seat configuration, right? You see that? Okay, so 4.3 is right here. This is a truss girder coming in. You can see they got a different seat detail on this as opposed to.
Yeah, well, there's some notes on 4.3 and
Both pages are some of it's on 4.3 and some on 4.4.
Okay, so this is a, this is what the platforms and that's on the wall. You see that?
This is block wall of the shop.
This is the roof deck. This is showing here, the truss girder. That's a designation for a truss girder. That's the truss girder designation. This is your voice designation.
Okay, that's
Yeah. So you see how your truss girder is sitting in on the wall? Here, on the previous, this page. Okay, so you need to do the deck bearing. Wall's got to go up to bear the deck. It's going back one. And with the truss girder, you make it better. You got a deeper seat where your truss girder comes in. I'm sorry. See right here? This is a truss girder.
Might put
Does that make sense? So you got metal deck running perpendicular to the joist, it rests on the wall, the truss girder also rests on the wall. Okay? No, you have to get the wall up first, and then you actually gonna have a drop in the back wall for that to sit on.
The substance?
Yeah, you see the truss girder do that. So you got that rear wall supports both metal deck and truss girders. Okay, so we're all good on seeing how that at the rear of the building here, we've got to have that masonry wall up to support the metal deck, but we also have to have that wall up to support the truss girder. Okay, now, I don't know where everybody's at. I don't want to be too basic, but your designation here, you'll see this designation here on the bar joist. It says 24 watt. KCS3, a 24 KCS3. Does everybody see that?
Yes.
Okay. The Steel Joist Institute designates joist by series. Okay? So the current series is a KS series. Okay? Don't ask me what it stands for. It's not important. Okay? The 24 is what?
Center.
That's the depth of your joist. Okay? And that 24 KC3, your 3 is the strength of the joist, and it goes up. Okay? So you might, if you look at an old set of drawings, you might see an 8C4 joist, 24C4. Okay? We're now on this K series joist, so you're 24 inches deep, and it'll support a certain load. Okay, now we run perpendicular. What do you see here? We'll read that.
24G 4N 7.0.
Okay, now that is what's called a truss girder. Your truss girders are GN series and things of that nature. You'll have a kip load on it, like 6.2, 1.3, things of that nature. Okay, so the way that they framed this thing is that they ran truss girders front to back along these lines, and they ran bar joists this way. What's this denotation?
W16 by 26.
W1626. Everybody understand what that means? Okay. Okay, you got I-beam. Okay? The W means that it's a wide flange section. Okay? The top and bottom of a beam are called the what? Flanges. Okay? This is called the what? The web. Okay? So a W 16 by 26. Okay? The approximate, and I do say approximate, the approximate height of a W16 by 26 beam is 16 inches. It's actually usually a little bit different than that. Would have to look at my steel book. It might be 15 3/4 inches. It might be 15 7/8. It might be 15 1/2. It may be actually 16 inches, okay? But the first piece of this is the depth of the beam. What is that? Weight, pounds per foot. Pounds per foot. So if you've got a 70-foot distance times 26, how many pounds of beams do you have?
Figure.
You got 70 feet of beams. They weigh 26 pounds a running foot. Yeah, somebody get a calculator, tell me. 1,820, almost 2 tons of beam, almost a ton of beams there. Okay, see how that hooks back into your equipment? What do you have to lift? Okay, so we know from looking at the plans here, we won't go through the front details, but we've got an idea how the steel frame is going to fit on top of the masonry, right? We see that the perimeter walls on this building, at least the rear wall and the right side wall, are what? Load bearing. Load bearing. So when we get back to our schedule, which is Knowing how to read plans helps a lot with schedule, that's for sure. All right, we know that once those footings are poured, and we call that our activity, and what block number was that? H, wasn't it?
G was the four.
H.
H.
And that was activity H. What's the next thing we're gonna do? H.
Four.
Yeah, I is gonna be lay block. Okay, now what do we have to lay those walls? Gotta have the block, you gotta have mortar, you gotta have sand, you gotta have wall reinforcement, you gotta have concrete reinforced rebar, right? Yeah, scaffolding. Anybody gonna go in and out of the back of those shops? Door frame. Okay, can't lay without a door frame. So on the procurement side, we got doors, door frames. Okay, we got block, Durawall, sand and mortar. You might even need water, right? Okay, block, water, okay, you're gonna have embeds, right? When you look at those details there, that truss girder, when you look on that sheet 4.3, what does that truss girder tie to? Ken, look at it clean. That's an embed. See that thing right there? See that? What does that say? Read that to yourself. Yeah, read that to yourself. What builds into the wall? You see that? Let's get that for you. See that truss girder? Typical George girder. See what it sits on?